Okay, so I've posted a couple of A1 problems here, and I've also printed them out and given them to you. And so what I want to do is we're going to spend a couple of minutes in class just having you think quietly on one of the problems. I'm going to choose one of my favorites. I actually remember when they came up, this problem 2004, basketball star Shaquille O'Neal, completely fictional person, no relation at all to anyone who has ever played the game. Their team statistician keeps track of the number SN of successful free throws she has made in her first N attempts of the season. Early in the season, SN was less than 80% of N, but at the end of the season, SN was more than 80% of N. Was there necessarily a moment in between when SN was exactly 80% of N? So I'm going to just give you a couple of minutes. I'm going to give you 5 minutes to just think about this, and then we'll talk about how we might solve this. In general, when you're doing an exam and you have 3 hours to do 6 problems, what is the very first thing you should do? Read all the problems and see which ones do you think you can do and which ones do you think you can't do. Usually the earlier problems are easier than the later ones. I think I might have told some of you my father was taking a class in college on advanced communication theory. And you had 2 ships traveling at relativistic velocities. They might have been near a black hole. You had to deal with the communications, connections, dealing with relativistic effects. And so my father wrote, point the 2 ships at each other, and spent all of his time on the other 3 problems and got an A. Is he realized there was no way anyone in the class was going to say meaningful things about this 4th problem in the amount of time you had. Spend all the time on the other ones. Take a few minutes. How many of you have ever watched these competition shows where people have a challenge and you have a couple of minutes to plan, and then you have like 5 hours, 10 hours, whatever, to actually do whatever it is? It is extremely valuable to take those few minutes and really think about what you're going to do, because once you start, you get locked in. What happens if a problem you think was easy turns out to be hard? Move on, try something else. Some of the problems, you might have an idea, hey, I can do this by brute force. You might be able to brute force one of the problems in 3 hours. That's not a bad strategy. If you think you can brute force and do a completely exhaustive case analysis and get one Putnam problem fully right, we are not going for prizes on beauty. We're not going for prizes on elegance. It's, do you have a complete and correct proof? If yes, that's a valid approach, is to spend the time and go through everything. The problem is if you can't get through every case, or if you miss a case. In the real world, you would actually be able to write a computer program and check a lot of things. We've done this with the Project Oil, and try to find intelligent ways to code. You're doing it by hand is going to be a lot harder. When you have a problem, I just want to give you some general advice before I have you starting to think about this. Try to think about special cases. If they give me this problem, can I look at maybe a lower dimensional version? Think about, how do these numbers actually matter? So we were talking about problem 2004. It doesn't have 2004 in it, but it has 80%. Do you think 80% is an important number? Would this work for 75%? Would it work for 70%? Can you think of any problems similar to this where you might have the answer, but maybe this problem has a tweak, so you can't quite use a theorem that you might already know? And what can you do to build intuition on this problem? So, whenever you have something, if you can spend a couple of minutes and just do some calculations, let me see if this is reasonable. Let me play with it. Let me look at some cases. Let me try to get a feel for what's going on. Do I think this might be true? Have scrap paper. Don't be afraid to write a lot of things down on pieces of paper and then transfer it to what's going to be graded later. It's absolutely okay to do that. All right, any other general questions? All right, so I am going to let everybody take a couple of minutes now to look at the 2004 problem on Shaquille O'Neal. So I'll give everybody 5 minutes. I'm not expecting you to solve it in 5 minutes, but see what you can. Okay. So it should hopefully be recording again. So again, so the problem is 2004. She starts off this season shooting less than 80%. We don't know how much less. Just at some point early in the season, it was less than 80%. And at some point later in the season, it was more than 80%. Must they necessarily? Yes.
Well, Paul's just texting me.
He is in the Zoom. Okay, but thanks. Oh, no problem. Double checking. Yep, he is listed. He's here. So we start off less than 80%, but we don't know how much less. We don't know how many shots were attempted or made at that point. And then at some point, she is more than 80%. Must there be some point in time when she is exactly 80%? What theorem would you like to use? Intermediate value. You'd love to use intermediate value theorem. Can you use the intermediate value theorem?
No.
Why not? It's not continuous. This is the Star Trek transporter issue. Where all of a sudden you go from being on the Enterprise to now you're down on the planet and no time has passed. That doesn't happen with a continuous function. You have to go through all the intermediate points. Why is this not a continuous function? It's discrete. And so discrete problems are much harder. We don't have the tools of calculus available. How might you get some intuition as to whether or not this might be true? Yes, let's start doing some examples. So we'll do the 2004 problem. Sn is less than 80%, then greater than 80%. Is it ever 80%? Okay, so let's do a sequence of outcomes. So we'll do maybe M for miss and H for hit. Give me a sequence that you might start with.
What about just 0 for 1 and then?
Oh, sure, we can do 0, 1. So 0 for miss, 1 if hit. Okay, what do you want to do for the first shot? You don't have to miss. It just says at some point in the beginning of the season, right? It says early in the season, Sn was less than 80% of N. So how do you interpret that? Does that mean it was always less than N, than 80%?
What if they only take like 2 free throws? Oh.
So when they say early in the season, Sn was less than 80% of N, does that mean there was a value of N where it was less than 80%? Or for all N up to a certain point, was it less than 80%?
I would interpret it at a certain point.
I would interpret it as a certain point in time, it was less than 80%, not that it was less than 80% at every point in time. But of course, you might be able to argue that it's sufficient to just consider the case where it's always less than 80%, because there's got to be a first time when it exceeds 80%, and there's got to be a time when it was less than 80%. So you might be able to argue without loss of generality, we can assume it's always less than 80% up to a certain point. Because again, whatever sequence we have, if it's less than 80% and jumps up above 80%, then she just hits everything from that point onward. So if we're trying to show that it can't happen, we can say, well, it's enough to assume that it starts off less than 80%, stays less than 80% for a while. Or if it started off above 80% and then falls, could we just reorder the hits and misses so that it was always less than 80%? This is the type of care that you need to do when you're writing up a solution like this, is you have to say, without loss of generality, we may assume it is always less than 80% up to some critical point, because if not, we can just reorder so that she has all the misses in the beginning. And if it was never 80% beforehand, then that's fine. So, again, maybe without loss of generality, always less than 80%, then maybe 80%, then always greater than 80%, as can just hit all shots from here on. Reorder first few shots if needed. You want to make sure you put in enough detail as to what's going on. We may not need to do this, But if we want to, we might as well assume that, if she's less than 80% at some point, start with all misses. And if not, then there was some earlier point. This is somewhat similar to the Catalan numbers. But what we did is we looked at when was the first time you hit the main diagonal, and we broke the paths along that. So what kind of string should we look at? Give me an example. What should happen on the first shot?
Wait, 0, 0, 1, 1, 1.
Let's start off with just 1, 0, 0. And if we do 1, 1, 1, 1, we hit 80%. What if we do 0, 0? 1, 1, 1. What's the percent at this point? 60%. Two more ones. Now what do we get up to? 1, 2, 3, 4, 5, 6. Or maybe I want to do 3 more. So I'll do, okay. What am I at now? 75%. Now let's do another one. So that's 7 out of 9. That's about 77%. Right? Do one more. This is now 8 out of 10, which is 80%. If we had found something like this where it didn't hit 80%, then we're done. Here is the sequence. Do you think that there's going to be an easy sequence where you can show it never hits 80% exactly? Why not? It's a Putnam problem, right? You have to take into account, where is this coming from? If there was a really simple counterexample, it's not going to be a Putnam problem. So what does that mean?
Either there's a really clever counter.
Either there's a very complicated counterexample, or it's true. My favorite all-time question, which I constructed, was when I was teaching abstract algebra at Brown. For those of you who haven't taken abstract algebra, there's a set of objects called rings. And if you have certain additional properties, you're an integral ring. And so I gave them a set and I asked them, for 5 points, part A, is this a ring? And part B, for 15 points, is it an integral ring? What do you think the answer is for part A? Yes. The answer was no. Most people forget to check closure. And so 2/3 of the class wrote for A, it has to be a ring, else why would you ask B for 15 points? My absolute favorite question of all time that I've created. And again, this is playing with people, and if you know how people attack problems, you can often construct things to get them to go down certain ways. When you are reading problems like this, there will be traps to try to make you go in certain directions, to try to make you think about certain things. Really think about the problem, try to get some intuition. But remember, at the end of the day, it's a Putnam problem. What must be true about the solution to the Putnam problem?
So it's doable in average under half an hour.
It's doable, at least for the low levels. But what must happen when you see the solution? Why? What do you say? Right? There should be a nice way of looking at the problem. That doesn't mean that you can't solve the problem by a painful elephant gun case analysis approach, right? Have I talked to you all about my proof of Morley's theorem? Did I mention that in this class? I see some saying yes, some saying no. So as an aside, if you take any triangle and you trisect the angles, hopefully I've done this well, you get 3 points of intersection. What is true about that triangle? It's equilateral. So I have it in my office. I made a bet with one of my friends in grad school. We were walking into the office and he mentioned this and he said, it's a shame that there's no simple proof. Oh, no, there's it's very easy to prove this. He goes, it is? Yeah. You write down the coordinates of the points. You calculate the squares of the lengths of the 3 sides, and you show that the squares are the same. And so he begged me not that I couldn't, but that I wouldn't have the patience to finish before we graduated. And so if I'm able to do it, he owes me ice cream not to exceed $250. If I can't, I owe him dinner not to exceed $12.50. So I got it in about a year and a half. I mean, I did not just work on it nonstop. I worked on it occasionally. The best variables to use I found was like the tangent of 1/3 of the angles. And then every time the lines intersect, you clear denominators, you end up getting polynomials of degree, I think, 48 in the variables. You expand everything out using Mathematica, which was legal. You subtract, and you see that all the coefficients vanish and they're the same. And so this was a great example of just because you can do something one way does not mean you should. John Conway has the best proof of this I've ever seen, where he starts off with an equilateral triangle and reverse engineers to get the triangle you started with. For the Putnam problems, there's an elegant solution. There's this is how I should look at it. It doesn't mean that's the only way you're going to get it, but it's something that you want to be considering. There should be a nice way of looking at this. If I'm looking at it in the wrong way, my calculation could become very painful, and this might be an indication that I should look at it from a new perspective. So for the basketball problem, as we start doing this, it's looking like maybe we will always hit that 80%. So any thoughts on how we might solve this?
Suppose we have 0 basketballs and
We have what?
We have 0 basketballs.
0 to m?
We have already thrown balls.
Okay, so we've thrown m. Good.
And you got n successful,
Got n baskets.
and the ratio is n/m.
And that's going to be less than 4/5?
Yeah.
Okay, good.
We know if we can transfer m plus 1 over n plus 1 and n over m plus 1.
Okay, and what do you want that to be?
So we want that to be greater than 80% if the statement is false.
Good. So if she's eventually at 80%, there's nothing to prove. So we have to have a sequence. So there's got to be some point where we transition from less than 80% to greater than 80. And once we're greater than 80, she can just make every basket from that point onward. So we have to show that if we're going from n over m, which is less than 80%, to n plus 1 over m plus 1, which is greater than 80%, that is impossible.
And it's easy to show that this is impossible.
Okay, so now we have to use some algebra. So now what we would have is n plus 1 times 5. So 5n plus 5 would have to be greater than 4m plus 4. Okay. And now what?
And 5n smaller than 4m.
So best is if, do you want to do n is equal to, so what do you want to say for n?
No, the first equation can be
Oh, okay.
5n.
Okay. From first equation, we know 5n is less than 4m.
And contradiction because 4m is
So from this, we get 5n plus 1 is greater than 4m, but 4m is greater than 5n.
which means it's not integer. Because you're not in consecutive integers.
So what's the contradiction?
Because 5n is smaller than 4m, 4m is smaller than 5m plus 1.
Okay, it's strictly less than. So now we have 4m is an integer strictly between 5n and 5n plus 1 contradiction. Right? There's no integer strictly between two consecutive integers. So this is a really nice, proof technique. Any other ways to try to do this problem? Any other thoughts on how we might try to approach it? So is there anything special about 4/5?
Where the n denominator differ by exactly one.
So the question is more generally, let's generalize. So let's say we want n over m to be less than p over q, and then n plus 1 over m plus 1 to be greater than p over q. Yeah. Do we have to go through exactly p over q? So we would then get qn plus q greater than pm plus p, and qn is less than pm. Okay, so we would then get qn plus q minus p is greater than pm is greater than qn. So if q minus p equals 1, impossible. What if q minus p equals 2? Right, so the question is, this just means that it might happen. Is that a proof that if P and Q differ by 2, that it's possible to avoid? It's possible, yes, but can you actually give me a sequence? So for example, let's say P over Q equals 1/3.
Oh, yeah, and then 0 to 1.
So try 0, 1. Right? We find a counterexample extremely rapidly. So then the question is, will we always be able to find a counterexample for any fraction P over Q where P is at least 2 less than Q? So again, whenever you see problems, for the Putnam, don't worry about generalizing. But in life, if you see a problem, think, how can I generalize it? What was special about this 80%? How did they write 80%? Sorry? Is that how they wrote 80%?
Yeah.
How did they write 80%? So they wrote 80%. Do you think that was on purpose? Why? To make you think it's arbitrary. If you write it as 4/5, you're immediately writing it as a fraction, and that might have people looking at it in a certain way. So one of the lessons here is look at all the different equivalent ways you have of writing something. And if for something like this, 80%, that's not a really good way of looking at it, but 4/5, maybe there's something special about that fraction. Because we can definitely come up with examples where you're not going to hit certain percentages. So something must be special. It is worthwhile sometimes to see solutions that may not work or may not be good, right? It's a thought process. So what I'm going to do is I'm going to talk about, I deliberately looked at this problem. I did not really feel this was cheating because I actually do remember this problem from 2004. A lot of us were amused by the choice of name. So we have 4/5. So we can be thinking about what happens in strings of baskets. And maybe we look in blocks of 5. So why might we look in blocks of 5?
That's probably where the 80%.
Yeah, that's the 80%. The 80% is 4/5. So maybe let's keep looking at what happens every 5. So if you want a block of 5 to help your average, what must be true in that block of 5? They must be all hits. Or if you have a miss, you have a couple of hits and then. So we could look at, you know, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Those are the only possibilities. And so without loss of generality, I can assume that I'm less than 80%, and then something like this happens. So we assume less than 80%. So we have n over m. Okay. What's the closest you could be to 80%? Well, let's look at it another way. What must be true if we're going to hit 80% exactly? M is a multiple of 5. So it has to be of the form, say, 5k and n if 80%, as denominator must be a multiple of 5. Fortunately, we proved how to determine which numbers are multiples of 5, you know, foreshadowing, the art of a well-structured class, right? So we know which numbers are multiples of 5. Whew. Okay. So we have something that's less. And now we can just look at what must happen as we go up. What must be true about n if there's a chance that in the next set of 5, we're going to go high enough? If hit or exceed 80% in at most next 5 shots, and must be in what set? You know, let's say k equals 20, so I have 100 baskets that have been shot. Is it possible n is 3? If n is 3, could I get up to 80% with my next at most 5 shots? What can you tell me about the values of n? So if 5k is 100, what would be a good possibility for n to investigate? I'm sorry?
75.
So 75, 76, 77, 78, 79, something like that. 75 might be too low, but competitive. So maybe let's try, it's going to be 5k minus 5, 5k minus 4, 5k minus 3, 5k minus 2, 5k minus 1. If it's 5k minus 5 and I make 5 baskets, would that work? So I think we can immediately rule out 5k minus 5. Oh, I'm sorry, these should not be 5s. These should be what numbers? No, not n. These should be what? 4. Because I want to hit 80%. And so if n was equal to 4k, I would be at 80%. So I know n has to be less than 4k. Right? So it could be 4k minus 1, 4k minus 2, 4k minus, and so on and so on. It can't be 4k minus 5, because then even if I got all 5 baskets as hits, that'd be the most I could raise my percentage in the next 5 shots. And then that would get me up to 4k over 5k plus 5. It would not be enough. So I know if I'm going to hit 80%, it has to be when the denominator is a multiple of 5. So I can look at what's going on in these strings. So I now have 4 possibilities. And there's 4k minus 4, 4k minus 3, 4k minus 2, 4k minus 1. And I can look at what's going on for each of these. Okay. So we have 4 cases. N equals 4k minus 4, n equals 4k minus 3, n equals 4k minus 2, n equals 4k minus 1. If I have n equals 4k minus 1, is it possible that I could get up to 80%? How would I get up to 80%?
Make all 5.
Make all 5. Because remember, we're assuming we are at a point where we move from less than 80% to greater. So we're assuming move to 80% or more in the next 5 shots. So we know we have to move to 80% or more in the next 5 shots. If we have n equals 4k minus 1, what's the first time we'll actually make it to 80%? The next multiple of 5. We have to get 5 hits. If we got 4 hits, it would be a little bit less. So for this one, first time at 80% or more is 5 hits. We would now have 4k minus 1 plus 5 over 5k plus 5, which is 80%. Okay. Which is a better way to solve the problem? The first way proposed by the class or the second way proposed by your professor who's being paid to teach you?
First one feels.
First one, right? You know, I'm a big boy, you don't have to worry about hurting my feelings. Which way is worth more points? Same, trick question. They're worth the same. I can easily go through 4 cases like this. And if I look at what's going on for all these cases, you know, there's not that many possibilities. Even if I don't do anything clever, I've got 5 possibilities, 4 cases, 20. Well, up the sleeve, I can do 20 cases. That's not a problem. You know, I'll fill things up and I'll just write it down very clearly. And then with a little bit of work, I can say, well, you know, I can look at some of the extremes and I can see, you know, if I'm in, say, one of these situations, if I'm at 4k minus 3, if I've only done 2 baskets and I'm still at less than 80%, I know I don't have to worry about what happens if I just get 1 basket. If I do 3 baskets and I'm still less than 80%, I don't have to worry. So is it possible I could break 80% with 3 baskets? If I'm at 4k minus 3. No, because if I get 3 baskets, I would have 4k for the numerator and then 5k plus 3 for the denominator. So I know I need at least 4 baskets. So need at least 4 baskets, else the best is 4k minus 3 plus 3 over 5k plus 3. This is less than 80%. So I know I only have to worry about 4 baskets or 5 baskets. So study 4k minus 3 plus 4 over 5k plus 4. And 4k minus 3 plus 5 over 5k plus 5. Well, for the second one, is this going to be more or less than 80%? Less, because this is just going to be 4k plus 2 over 5k plus 5. Oh, 2 fifths. If it was going to hit 40%, that's going to be 4 fifths. So I know it's not going to be, I know the algebra, I don't even have to do it. For this one, it's going to be 4k plus 1 over 5k plus 4, less than 80%, less than 80%. So it actually wasn't that bad to do that case. For this case, what do I have to do? What's the only thing I need to worry about for this case? I have to get 5, because if I only get 4 baskets, I would then be up to 4K over 5K plus 4. Need all 5 baskets. So we get 4K minus 4 plus 5 over 5K plus 5. This equals 4K plus 1 over 5K plus 5, which is less than 80%. So what's the only case left? So we have to do, so consider n was, I think it was 4K minus 2. Yes. So we need at least how many baskets? 3 baskets. So it would be 4K plus 1 over 5K plus 3, 4K plus 2. Again, I would write it out a little bit more carefully. 4K plus 3 over 5K plus 5. And we can see in each one of these, all of these are less than 80%. So ratio is less than 80%. We're done. What's nice is because I'm recording this lecture, we can actually go back and see just how long it took to write all of this up.
So how does this help us?
Well, we've broken it up into all the different possible cases. We know that if we're going to be a multiple of 80%, the only way that can happen is if the denominator is a multiple of 5. So let's look at what happens when the denominator is a multiple of 5. There's got to be some point when we first go from being less than 80% to greater than 80%. So we can assume that we're at some multiple of 5 shots, and we'll assume we're at less than 80%. And then we'll see what happens after we shoot at most 5 more baskets.
You're saying that we can't get to 80.
Well, no, I'm saying in 3 of the cases, we see that we are still less than 80%. So our assumption that this was the set of 5 shots that pushed us above 80 is false. So we must be in this case where it is 1 less. And then when we shoot, we get 5 straight baskets, and then we go over. We then hit 80%. So if we're going to hit 80% exactly, it's got to be at a multiple of 5. We have to have some period where we go from being less than 80% to being 80% or greater. And so let's assume that somewhere in the next 5 shots, we go to 80% or greater. For those 5 shots, if you want to improve our percentage, we clearly can miss at most twice. At most once in the set of 5 shots. And so if we want to increase our percentage, we've got to start off with a hit. If we do hit miss, we're going to be lowered. So it's enough to just look at hit, 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 like this. Because if I had hit, miss, hit, that's 2/3. That's going to lower myself.
How does this show that there's a case where we get above 80% and don't hit 80%?
Well, we know eventually we have to hit. No. This is showing that you have to hit 80%. In these cases, we showed that we actually don't break 80%. We actually stay below 80% in the next 5, no matter what happens. And that contradicts the assumption that this was the set of 5 that pushed us to 80% or above. And so of the 4 cases, the last case, it is possible to get to 80% or above by making all 5 baskets. In the other cases, we started below 80% and we stay below 80% no matter what happens. It's just, we have too many misses that we're not able to recover. So this is a far worse proof, okay? So it's sometimes nice to be able to show worse proofs, because I think this is a fairly natural way to look at it. All right, I've got 80%, I'm taking 5s, let me look at multiples of 5. What must be true if I'm to have a chance of hitting 80% or greater? I've got to be at least so close. I've got a bunch of cases. roll up the sleeve, do the analysis. Later in the semester, we will learn how to do Rubik's Cubes. I will have to stop now. That clock is not set properly. So I apologize for going a little bit late.